Okay, guys. Today I wanted to walk you through a project that I've been working on for the past couple weeks. I meant to present it a few days ago, actually last weekend, but I couldn't get the live stream working on the new YouTube setup, but I think I figured it out now, so I thought I'd do this third or fourth time. So one of the things that I've been working on at work the past few weeks is an alternative to a platform called Apache Cordova, and we use Apache Cordova and we only use it for the Android platform right now. And what we do is we host our our product UI, which is a web app, inside an Apache Cordova shell, and then we use plugins to do things like talk to native Bluetooth APIs, talk to the native Wi-Fi APIs, interact with the file system, and various other things like configuring the device on our own to the way that we need it. And we do that using Cordova plugins. One of the things about Cordova is it's tried and tested, and it's a very mature technology, but developing plugins for it is error prone and the developer experience is not very good. So as soon as I started working on Cordova plugins, I immediately started looking for an alternative. And I didn't have a good alternative. There are things like Flutter, and there are things like React Native and Xamarin and a few other technologies. But I didn't feel like our organization was ready to jump to one of those platforms, because we also work on Windows platforms as well in addition to Android, and we needed to be able to support Windows, and the Windows support for Flutter is still in development. And React Native, it might be there, but I'm not a huge fan of React Native. Apologies in advance to anyone that is. Don't mean to offend. So I didn't have a good solution. But I went to the Android Dev Summit last year, and I talked to the WebView engineers. And one of the solutions that they came up with was to use something called web message channels. And they basically provide exactly what we need, which is the ability to get messages from the JavaScript hosted in the WebView and respond to those messages on the native side. And so that's the basis for this solution. And I didn't have a clear vision on it, but I've been monitoring and looking for patterns or examples that do that. And a couple weeks ago, I found this answer on Stack Overflow that showed how to set up the message channel that talks to how to create the message channel for the Android WebView, and then pass over the port that message channel has to the JavaScript side, so that the JavaScript side, which is our web app hosted in the WebView, could talk back to the native code, and then how to get that native code to handle those incoming messages and respond to them. So this is the answer right here on the left side, and it has a full project here in zip format that you can download and you can get going on, and it walks through how it creates a message channel. It gets the ports from that message channel. It adds a window event listener, and this is on the JavaScript side, so this would be hosted inside your web app, and it also shows the native side. So on the web app, what you're doing is you're basically creating the message channel and you're getting the ports from that, and then you're adding an event listener on your window. And so when the native side sends you a message that has a port, you assign that port to one of the ports that you've created here, which in this instance is port 2. And then that is basically your output port, which allows you to talk to the native side. Done in, for instance, this is done in JavaScript and pure JavaScript, and this is something you place in your assets folder that your WebView could reference. And this is something that would be on your native Android side. What we're going to look at is a multi-platform solution that's going to use Kotlin to not only generate our native Android code and to interact with the Android framework and SDKs. But we're also going to use Kotlin to create this JavaScript side. And then additionally, we're going to use Kotlin to generate the HTML. So I'll talk through it a little bit of some of the advantages we get from this. But just up front, one of the things we get is we're able to do all of these platforms in a known language right now, which is Kotlin, in a singular language. And it includes strong typing. And then I'll show you a couple areas where we're able to share the types between both JavaScript and our native Android code, which gives us type safety on both sides of the bridge or across the bridge. So without further ado, let's get into the project. And I highly recommend, if this is something that you're looking into, if you're looking to get off Apache Cordova, this is a valid solution in my opinion. We're still iterating on it. And I've also looked into implementing this on iOS as well and other platforms using Kotlin Multiplatform, but I only have the Android solution done now. And the project we're going to be going through is a web app that talks through this bridge that I just outlined to you to interact with the Bluetooth APIs to connect to another Bluetooth device and send information to that or send data to it in messages and to get messages from it. So now that I've said all that, let's look at the project. So the first thing I want to show you is kind of the layout of this multi-platform project. This is the first iteration. I've got another project that I'm working on that is meant to talk to a hardware device. But in this first iteration, to make things easy to understand, I've basically got three modules. I've got an app module, which is where our Android app is hosted, or where our Android source code is, as well as a lot of the source code related to our interaction with native Android APIs. It's also where we set up the native side of the WebView message channel. I've got a Bluetooth Serial.js module, and this includes our Kotlin JS code that we use on the JavaScript side, and this will generate some JavaScript files that we'll include in our assets folder that will be then loaded in a web view when we launch our app. And then I've got a shared code. All that means is in our Kotlin multi-platform project, we're going to be using our Kotlin multi-platform plugin, and then in our Bluetooth Serial.js or our Kotlin JS module, we're going to be using our Kotlin JS plugin. So let's walk through the shared code first, and then I'll give you a little bit of a deeper dive into how the bridge works. So in our shared code module, we have right now just two platforms that we're targeting. One is Android and one is JavaScript. And let's look at what we have shared between both platforms. So one of the things that we're going to do is we're going to send messages back and forth between the JavaScript side and the native side. And because of that, both sides need to know kind of what the messages look like. And so from the JavaScript side, we're going to send a JavaScript message to the native side. And I'm going to go through some of the shared types, and then I'm going to go through how it works, because I think that'll provide some context as to why these types are the way they're at and how the importance of them. So our JavaScript message includes 4 properties, and one of the properties is an action, and that's the action that we want to take from the JavaScript side. So we're developing an app that is going to interact with Bluetooth. So one of the actions that we want to take from the web app is to connect to another Bluetooth device. Another action we want to take is to send data to another Bluetooth device. We also want to take an action if we're not the initiator of the connection, is to listen for incoming connections. So we're going to have an action that's listen. And then what we've got is we've got 2 callbacks here. One is a success callback and one is a failure callback. And these callbacks are basically identifiers, so that when we get a message back from the native side, we're able to determine where that message should go. So, and then we've got a data property here. And this is basically a string map. It's optional, default value of null. And this allows us to pass some data to the native side. And for instance, if we're going to connect another device, one of the pieces of data that we'd like to send to the native side is the MAC address of the device to connect to. So let's look at some of the actions as well as some of the definitions of the callbacks and the data. So our actions are in enum, and here are some of the actions: connect, disconnect, send, listen, get address. This allows us to get our MAC address from the native side. And then we've got some callbacks here. So we've got a connect success callback and a connect failure callback. And so if we were to initiate a connection to another device and it was to be successful, the native side would send a message back that is associated with the successful callback, and then the JavaScript side would know what to do with that data or with that response. So let's look at what the native data message looks like. So the native data message includes the callback, and we just saw that callback here. It's in enum as well. And for some reason it's not annotated with serializable, but it seems to be working, which is interesting. So one of the things I'm going to fix right here is just to make sure that is serializable. I'm surprised that this has been working. So we're going to, so our native data message is going to include the callback that we're responding to, as well as some data associated with it. And let's say if we were, if we registered a data listener on the Bluetooth serial connection, one of the messages that we would get back is that data that's coming across the line. So if we register a data listener and the device, the remote device that we're connected to, sends us a message, we would encapsulate that data, that message inside this data property. And then we've got just this generic common file, and that includes some of the keys that we're using. So one of the keys that we're using when we connect to a device is a MAC address, and we have it specified in the common folder because both the JavaScript side and the native side will need to know the key to get the MAC address, to assign or get the MAC address from. Okay, so I kind of got a little bit ahead of myself and showed you some of the common types that are shared between both platforms. Let me show you on the Android side how we're setting up that message channel. So I'm going to go in here and I'm going to open up my project, and we're going to first look at the main activity and show you how simple it is. Really, it's just a view that has a web view, and we pass that web view into this web view config file, or class I should say. It configures it. This is borrowed from the project that I referenced from Stack Overflow. And then what we do is we create this web view client, and we associate it with that web view. So this web view client, what it's going to do is when the page is finished loading, and our page here is just a index.html file hosted on our Android assets directory, which we can see here. So what it's going to do is when the page is finished loading, it's going to create this JavaScript message handler. So let's see what happens there. This is a key part of the bridge. So our web view message handler, an important piece of it is to create this web message channel, and it's something that allows you to post messages between, I think, windows, or between like frames in a window. I'm not that familiar with web technologies, but I think that's what it's commonly used for, or perhaps even different sections of a web page. And what we're going to do is we're going to get web message ports back when we create that channel, and we assign it destination port. And then what we do is we post a message to the web view with a key of capture port, which is in our common code. So the JavaScript Kotlin.js knows that that's an important key. And then we pass it that destination port that we added to this array of ports up here. And what this is going to do is this is going to give a port to the JavaScript app that allows the JavaScript app to send messages to our native code, and those incoming messages will be handled. And we can see right here that we are setting on port 0, or the first port, a web message callback. So basically we send it the second port in that array, and that array is going to be how the web app can talk to us, or the JavaScript code, and the other side of that port is going to be all the outgoing messages from that port. So what we're going to do is we're going to set a web message callback, and that message callback is defined right here on init of that class. And we can see that we've overridden on message, and what we do is we check for the data, and then we deserialize the JavaScript message, which we went over earlier, which is the JavaScript message type, which both Kotlin JS and native Android know about. And then what we do is we parse the action, or we do a when statement on the action of that JavaScript message. So if the Kotlin JS code sends us a connect action, then we execute a connection or a connect function with that MAC address, as well as a success callback and a failure callback. We're going to send a message to the Kotlin JS code, or the JavaScript side, with a key, and the key is capture port, and we're going to send it the port so that the JavaScript side can send messages to. So we can find out where we do that in the JavaScript side by just doing a find usages on this shared or common key. So let's go over here. It's in our Bluetooth serial KT file. And let's go all the way down here, because this is just our import statement. And we can see that we've got this method right here, or this Kotlin JS. So what we do is we grab the window that this file is loaded in, and the output of this file will be a JavaScript file. And we add in an event listener of message, of type message. And then when we get those events in, we're really only checking for message events. And we check the data field. And if it doesn't equal key capture port, which is what we're interested in, we just send that message back along for other listeners to use, or listeners of the input port. And now that I'm reading this, I think I found an optimization or an improvement. But if it is capture port, what we do is we take that port that was sent to us and we assign it to the output port, which is defined up here. It's just one of the ports that our message channel has. And this port right here is what we can talk to when we want to send messages to the native side. And then what we do is, because we've now got this output port assigned, we could probably do this above, but it's only able to be used really right now, is we create a message handler that our Kotlin JS code can use to send messages to the native side. And I'll show you where we call this configured channel message. So what's really beautiful about this that you can't do in Apache Cordova is do like find usages across the JavaScript code and the native code. If I were to load the JavaScript code in Android Studio right now without a special plugin, I probably wouldn't even get type safety or any syntax checks. But let's go to find usages, and let's look at this. Here we have a main function in an index.kt file. And what this file is going to do is it's going to generate an HTML document. And we can see the first thing that it does is it calls Bluetooth serial, which is the name of the class that's going to be generated from this Bluetooth serial module, serial.js module. And it's going to call configure channel, which is going to put the web app in a state so that it's ready to get that port message sent to it. So if we remember earlier, when the page is finished loading, which means that this code has already been executed, the WebView client code is going to initiate that JavaScript message handler, which is going to send that port over to this configure channel, this listener that's defined and added in this, I should say, and added in this configure channel method. So once this is all set up, the page is going to be finished, and we're going to create that message handler. We're going to send the port over so the JavaScript code knows what to talk to. And then our channel is set up so that both apps can talk, so both sides of the bridge can talk to each other and receive messages from each other. We then have some generic code here, which is going to find the root element of the document that is there. And so we do have some generic HTML code here that is hosted in our assets folder. And we can see these are the important parts, is that 3 files are generated. I don't have the greatest implementation of Kotlin Multiplatform, but you can see that we're loading the Kotlin JS library up here. We're loading the shared code JavaScript file, which is going to expose these common classes as well as anything in this JS main directory to our JavaScript code. And then we're loading the Bluetooth serial.js file, which is the output of this module. And that code also includes, which was defined right here, up here. That's where we have the script below the definition of this root div. And then it's going to add some buttons like connect to device. And let me see if I can fire up a emulator here and show you what this will look like without too much trouble. Okay, so I'm running low on space here. I think I have a picture of it. Let me open it up over here and see if I can show. Okay, so ImageMagick was able to load it. I'm not certain why the image viewer in Ubuntu wasn't able to. But just real quick, let me resize this and close this Gradle folder. Oopsie. We can see we've got a button defined here with text connected. And we're going to pass it this MAC address, which is the MAC address of a Samsung phone I have here. It's a Bluetooth MAC address actually. And when I call this method or this function, it's going to call some JavaScript code that'll then send a message across the bridge that then the native code will act on. So let's look at what this connect function does. We also define 2 callbacks. One that they both basically log whether it was a success or not. So here we go. Here's our connect function in our Kotlin JS module. So the first thing we do is I've got a helper function here that registers the callbacks. And what we do is we take our enums for our callbacks, and then we associate them with the actual implementation of these callbacks, our on success and on failure, and then we specify whether we should remove them. And the removal is basically if they're single use. So some callbacks are basically once we get a message back, once we send a message out, when we get it back, remove the listener. Some are like we want to keep the listener there, and those are like a data listener. So if we're getting data across our Bluetooth channel, we want to keep that message active, that callback there, so that incoming messages can still be processed. So so that's our register callback function, and I'll drill into that later. And then we construct our JavaScript message with our connect action. Again, these same callbacks, which we're going to send to the native side so it knows what to call back to. So once it does a connection, and then we're going to pass it this key MAC address, and then we're going to send it to our message handler, which I showed the definition of earlier. But we can see right here the implementation is that it will stringify this JavaScript message using our Kotlin X serialization multi-platform library, and it's going to post it to that output port. So there we go. So let's look at just a little bit in our register callbacks. So this code is a little bit terse or hard to understand, but basically right here we're creating a callbacks map here with the enum ID or with the ID and with the callback itself. And then we're creating this event listener that we're going to add to the window so that incoming messages, and we could use the existing one, but this implementation creates a new listener for different types of incoming messages. And then what we do is when we get these native data messages in, we're going to deserialize them. And then if we find, if it has a callback associated with that incoming message, we're going to we're going to look for that callback in our map that where we did that assignment. And if we find it, we're going to invoke it. And if we remove callbacks, we're going to remove the success and failure callback that were passed in. If not, we're going to keep them there to be invoked again later on. So let's look at up here our connect function. We created this JavaScript message. We have an action, we have some callbacks, and we have a MAC address. Let's look on the native side implementation and what happens over there. So I happen to know the name of that class, and it's Bluetooth Serial as well. So here we go. Let's check out our connect method and see what we do here. So our connect, ooh, you know what? Here, let's find out what calls this actually. We saw it earlier. So here's where we get those JavaScript messages. We are going to deserialize it over here, use this when statement. When we get that connect action, we're going to call our connect function on the native side. And basically what it's going to do is try to connect to that device. It doesn't check that it's actually connected, but it initiates that connection. And after it does that, if there's a success callback, it generates a native data message. It associates the success callback with that, and then it sends it back over to across the bridge. If it's not, if it doesn't find the device to connect to, it sends a failure. And that's basically it. With this, we have the foundation for our Kotlin multi-platform Apache Cordova alternative. And we're able to do all our development in Android Studio. Let me see here. We can just hit play and deploy the app. So let me see if I can use one of these. Let me try Toast. Maybe Toast will start up. And we have full debugging. I'm going to see if I can show you how we can even use breakpoints, even though we're going to be using a web app to interact with native Bluetooth APIs. So if I can get an emulator to start up here, I'll show you that. So let me try over here. Let me start Toast and see if it'll fire up. I'm having a few emulator problems today. Okay, so here I've got a Clover Emulator, and I'm going to hit play. We'll see what happens. Okay, so we can see that something very similar to this other app was rendered. And I'm going to hit this debug, and I've got this connected device button here, which I just went through the implementation of, and I've got a breakpoint set. Let's see what happens when I hit connect to device. Boom. We've got this on message handler. It got a message from the web message port, and it found that the action in the JavaScript message was an action of connect. We've got our success and failure callbacks. And here we go. And we've got our data, which is the MAC address to connect to. and it's calling our connect function. So this will fail because this emulator doesn't have a Bluetooth adapter, and it might actually fail catastrophically. Yeah, so there we go, it crashed. But the beauty of it is we're able to iterate on a plugin, if you will, for a hybrid app and using Kotlin Multiplatform, which is something that I haven't been able to do in an elegant manner using Apache Cordova. And if this is something that we didn't want to create a library out of, we could have all our code in just one project uploaded to GitHub, and we could just iterate from that single project without having to worry about complex build scripts that copy over files from various plugins. And that's that. So that's my brief walkthrough. If you have any questions or comments or suggestions, please include them. If you have anything I'd like to talk about in a further video, please let me know. And I really appreciate you watching today, and I hope that you were able to learn something, and that maybe even you'll be able to iterate on this and create something better. Thank you, and have a good day.